All right, today we're taking a look at graphing the most simple rational functions. What is a rational function? It's a function where you have one function stacked on top of another function. So f of x divided by g of x, this would be a rational function. The most simple rational function is called the reciprocal function. It looks like this. Y is equal to 1 over x, where 1 is f of x here. And then x would be g of x. All right. The type of graph that this is just a reciprocal graph. Okay. And then before we talk about any of the rest of those lines, let's just fill in a table of values for this graph. So the function is y equals 1 over x. So let's make an x and a y with these points. So like good points to plug in is like 1. 1 would be a great first x value. So 1 divided by 1, that gives us out 1. 2 would be another great x value. 1 over 2 would give us 1/2, right? If we plugged in 2, we'd get out 1/2. And then I like a little bit less than 1, so what if we went with 1/2? So that'd be 1 divided by 1/2, which is the same as saying 1 multiplied by 2 over 1, because dividing by a fraction is the same as multiplying by its reciprocal. And then 1 times 2 over 1 would just give us 2. All right. We could also plug in negative numbers for 1 over x, so that'd be x, y. So we pick some negative numbers, like -1. So that's 1 over -1, which would give us out -1. Let's just pick the same numbers but negative. So -2 would be 1 over -2, which would give us -1/2. And then -1/2, so 1 divided by -1/2, would give us out -2. Let's plot those points. So -1, -1, -2, -1/2, -1/2, -2. On the other side, we have 1, 1, over 2, up 1/2, 1/2 to the right, and then up 2. Hopefully, at this point, you can start seeing that there is asymptotes in this type of graph, specifically a vertical asymptote and a horizontal asymptote. If we would draw those in, the vertical would be right here. Let's try that again. Hold on. So our vertical asymptote would be right here. Our horizontal asymptote would be right here. And then, if we connect the dots and make sure we hug the asymptote lines, we can draw this graph. It's like this. And then on the other side, it'll look like this. And there's our graph. All right. So that vertical asymptote ended up being x is equal to 0, right? Here's our vertical asymptote. Our horizontal asymptote ended up being y is equal to 0, right here. The domain of this function would be from -infinity to 0, union 0 to infinity, because it skips over 0 in the domain. Or you can write all real numbers. X cannot be 0. For the range, we do the same thing, -infinity to 0, union 0 to infinity. Or again, you can say all real numbers, but this time y cannot be equal to 0. All right? So the reason we have this vertical asymptote is because we have to think about this equation, right? We cannot take 1 and divide it by 0. This is not allowed to happen, so we're never allowed to plug in x. We're not allowed to plug in 0 for x, right? So that makes the vertical asymptote. Thinking about the horizontal asymptote, this is a little bit harder to comprehend, but right, as we go to the right forever, say we plug in 1 million into this equation, then we would get 1 over 1 million. This does not equal 0. It's 1/1,000,000th. But this is really close to 0. So no matter what you plug in for x, you're always going to be a number. It's never going to quite be 0, although it keeps getting closer and closer to 0. Same thing if you went to the left, right? -1 million. Really close to 0 when you put 1 over it, right? But it still is not quite 0. It's just a little bit negative. So talking about the standard form or the transformation form, this is f of x is equal to a over x minus h plus k. Our h value, still the horizontal shift. If it shows up as plus in the equation, that's a shift to the left. If it shows up as minus in the equation, that would be a shift to the right. If k is the vertical shift, if it shows up as plus in the equation, we would shift it up. If it shows up as minus in the equation, we would shift it down. If the a value is negative, the function is reflected or flipped across the x-axis. And if the a value is bigger than 1, that would represent a vertical stretch, while an a value between 0 and 1 would be a vertical shrink. All right. The vertical asymptote is going to be x is equal to h. How do we get there? Because we have to think what x value makes that denominator 0. In this case, it would be h, right? X minus h cannot be equal to 0 because we can't divide by 0. So if we add h to both sides, x cannot be h, which tells us that the vertical asymptote is at x equals h. Horizontal asymptote, on the other hand, is a little bit more confusing. This is y equals the k value, would be our horizontal asymptote. The reason this one is a little bit more confusing is because we just have to think about what is going on here. And I know it's hard to maybe comprehend this, but as the number down here gets really big, right? So as you plug in numbers that are going this way, this entire portion of the function gets close to 0. So then if you have something that's really close to 0 and then you add k to it, the value of f of x is approximately k. So it's just getting closer and closer to k as you go to the right further and further. And then as you go to the left further and further, it's going to get closer and closer to k as well. All right. So the reciprocal parent function is reflected across the x-axis, then translated 4 units right and 3 units down. Write an equation to represent the new function. Identify the asymptotes. So reflected across the x-axis, that is an a value of -1. Translated 4 units to the right would be an h value of +4. And then 3 units down would be a k value of -3. So when we write this, it's f of x is equal to, and then our a value is -1, divided by x minus h, so -4. And then plus k would be plus negative, or you can just say -3. The vertical asymptote is x equals 4, and the horizontal asymptote is y equals -3. The reciprocal parent function has a vertical asymptote located at x equals -2. Vertical asymptote is the h value, so h equals -2. The horizontal asymptote located at y equals 5 is the k value, so k is equal to +5. So then one representation of this equation would be 1 over x and then minus -2 plus 5, so that becomes 1 over x plus 2 plus 5, right? There's our equation. Okay. And then on to the graphing. It says graph each function, identify the domain, range, and asymptotes. To start these, I always like to do the asymptotes first. Remember, vertical asymptote is the h value, horizontal asymptote is the k value. In this case, k is -2, so we have y is equal to -2. Our vertical asymptote, there is no plus h here, so it sticks right at the center line or the y-axis, so that's going to be x is equal to 0. And then we can draw those in. So we have x equal to 0 right here, and we have y equals -2 right there. From this point, I like to, I guess, write the domain and range, right? So we're all real numbers. X cannot be 0. All real numbers, x, or not x, y. Y cannot be -2. And then we look at just the a with the x. So then this is y equals 1 over x, and we build our table. 4 is the maximum points you have to have. You can go to a minimum of 2 points here, but let's go 4 for these first 2 graphs. So if we're going 4, well, let's plug in 1, so 1 over 1 gives us 1, and then let's plug in 2. 1 over 2 gives us 1/2. right? And then we'll plug in the negative versions of that to give us -1 and -1/2. So then we plot them. So we have 1, 1. We have 2 up 1/2. We have -1, -1. And we have -2 down 1/2, right? As soon as we draw in these asymptotes, we treat that middle point as our new origin, right? So then we can just plot all these points to the new origin and then draw our graph. So it'll look just like this. Okay? Let's take a look at another example. Let's go 5 right underneath of it. Asymptotes verse vertical asymptote. Again, no horizontal shift here, so we're going to just say that this is x equal to 0. Our vertical shift does go up 1, so our horizontal moves up 1, so y is equal to 1. Domain, all real numbers, x cannot be 0. Range, all real numbers, y cannot be 1. So we're at +1 right here, and then x equals 0. Right here. Now that we have those 2 points, we look at just the a value with the x. So -4 over x, right? We treat this new center where our 2 asymptotes meet as our origin. So we have y equals -4 over x. So then we plug in some nice numbers, right? Always plug in 1. 1 is always nice. -4 over 1 just gives us -4. Could plug in 2 here. -4 over 2 would give us -2. And then I always like to go the negatives of what I put the first time. So -4 over -1 would give us +4. And -2. So -4 over -2 gives us +2. So -1, +2. -2. Oops, -1, +4. Why did I say 2? -1, +4. -2, +2. And then on the other side, we have +1, -4. And then we have +2, -2. And then here's our graph. Whoops. By all means, if you need more points, graph more points. If you see it with just 4, graph 4. That's awesome. Okay? Last but not least, let's take a look at number 8. Number 8 is about the hardest one that you would see. It could be like a 2 value right there or something, but that doesn't change how we would work this question too much. So vertical asymptote, this time we do have an h value. In this case, it's 5, so x equals +5. Our k value is 3, so y equals 3. So then we can, let's say domain and range, and then we'll graph. Domain, all real numbers, x is not 5. And then our range, all real numbers, y is not 3. Again, you can always be writing these as interval notation, -∞ to 5, union 5 to infinity. Or this would be -∞ to 3, union 3 to infinity. Both are great ways to write that domain and range. Then we put them in there, right? So x equals 5 is here. Y equals 3 is right here. And then lastly, we just take the a value with the x. So we have y equals -1 over x, and we build our table, xy. Again, like I said, you could, once you get good with these, you only need 2 points. So -1 over 1. So say we plug in 1, that would give us -1. And then if we plugged in -1, you would get out +1. So 1, -1 is here. -1, +1 puts us here. And then you just need to make sure it's a nice smooth curve. Just like this. And just like that. Okay? And that is graphing our reciprocal function. As always, if you have any questions, please let me know. I'd love to talk about them more. You do not need to finish those other 3 graphs that we did not do, but if you just need more practice with this stuff, this is a great place to come back to and practice a couple more graphing questions. All right, have a great day.